Good morning, students. So in the last class we discussed about the valence bond theory. Okay, so we discussed already Lewis concept, that is the dot structure, and valential electron pair repulsion theory, that is PSE/PR theory. Okay, so then we studied already what the lone pair electrons, how the shape of the molecule is designed or assigned. Okay, next one, that theory helps to explain the overlapping of the atomic orbital. So that is overcome by the theory valence bond theory. So valence bond theory tells about what? Only the overlapping of the atomic orbital, means the formation of the sigma bond and the formation of a pi bond. Are you getting? So in the sigma bond, axial overlapping takes place. In pi bond, sideways overlapping takes place. In sigma bond, types are there. Three types. One is SS, SP, and PP sigma bond. But in pi bond, only one type, that is PP. Only p orbital overlap with each other to form what? Pi bond. Okay? S orbital cannot form. And also later, these explain successfully the shape of the molecules also given. Understand? So the based on this valence bond theory. Okay. So the next theory is introduced. Of course, the valence bond theory is a introductory part or a well-defined concept for next hybridization. Okay. So the next concept is hybridization. Okay, so what is meant by this hybridization? So students remember, hybrid means what? Mixing of or a mixture of two or more, like. Okay, so hybrid orbitals means, so the mixture of two or more orbitals or two orbitals is called as what? Hybridization. For example, one s orbital is there, one p orbital is there. They mix up with each other. They form sp hybrid orbital like this. This is the sp hybrid orbitals. They mix up with each other. Are you getting? S orbital and p orbital. So they form what? Sp hybrid orbitals. So one s orbital, two p orbital, then sp2. Similarly, sp3. Types of hybridizations are there. Just remember, what is hybridization means the mixing of atomic orbitals to form a different orbitals. Mixing of atomic orbitals is called as hybridization. I write here the mixing up of atomic orbitals. Okay, so these are called as hybrid orbitals, and the process is called as hybridization. The process of mixing of atomic orbitals is called as hybridization. So students, initially I will write the what is that silent features of this hybridization, which are important for 3 months. Later I will explain the types and their structure. Okay, so listen. This is say features. You may take postulates also. Silent features of hybridization important for all the postulates. Even Lewis concept, BSCPR, BPT, hybridization, and the next one, molecular orbital theory. Both are important. Both the postulates, each and every theory postulates are important for 3 months. Okay. So the first one is the hybrid orbitals are equivalent in energy and also shape. First one, the hybrid orbitals are equivalent in energy and shape. Later I will explain these points. Okay. The second point is the atomic orbitals taking place in hybridization. Hybridization must have same energy or small difference in energy. Same energy or small difference in energy. Okay. Next, the number of hybrid orbitals forward is equal to the number of atomic orbitals involved in hybridization. Okay, next. Fourth point, both are filled and completely filled. Both are filled and completely filled orbitals also involved in hybridization. Both orphaned and completely filled orbitals are also involved in hybridization. The next one. The hybrid orbitals are more stable than bonds. Next, the last one, the types of hybridization. Types of hybridization defines shape of a molecule. So these are the postulates of hybridization. Are you getting? So what is this first one? So the hybrid orbitals are equivalent in energy and shape. Next, the atomic orbitals taking place in hybridization must have same energy, a small difference in energy. Next, the number of hybrid orbitals formed is equal to the number of atomic orbitals involved in hybridization. Means, for example, one s orbital is there, 2s orbital is there, they are mixing up with each other. Okay, then two hybrid orbitals will form sp. Okay, so later I will explain. Okay, listen now. So both orphaned and the completely filled orbitals are involved in hybridization. Means, for example, if we write any configuration, okay, so in that both orphaned and completely filled, incompletely filled also in one group. So those are involved in what? Hybridization. So I'll explain each point with an example, then you will get an idea. Then the hybrid orbitals are more stable than bonds, and the type of hybridization defines shape of a molecule. So listen, I'll go with the first one. What it is? The hybrid orbitals are equivalent in energy and shape. Okay, listen. For example, listen. S orbital is there. The shape of the S orbital is spherical, and p orbital is there. The shape of the p orbital is dumbbell. Okay, so students, when these two are mixed together, the hybrid orbital formed is. So mixing up, these two are mixing together. I will write here initially how the mixing up takes place. Like this, they are mixing up takes place. Means instead of overlapping, they get mixed up. Okay, then they get partially S character as well as partially P character. Are you getting? Initially the bonds what I explained, that is only overlapping. Overlapping means this is the S orbital assumed. As I told you initially. Okay, so this is the S orbital. Okay, so this S orbital is there, this is the P orbital. Okay, so they overlap on the surface, they are not mixing up. Okay, they overlap means they cover the surface area like this. If the surface area cover is more, means overlapping is more, the stronger is the bond. That is what explained in the before class. Okay, now the mixing up takes place, means this is the one orbital, this is the another orbital. Listen. Okay, so this is S orbital assume, this is P orbital. That gets mixed up, means this is mixing up with this is mixing up with this. Of course, here we are getting two different orbitals. This is having P character as well as S character. This is also having P character as well as S character. Means they gets mixed up. Mix up means they'll get a partially equal character of two orbitals. I hope you understand. Mixing up is different, overlap is different. When they gets mixed up, S orbital and P orbital, then what happens? They form a hybrid orbital. So students here, one S orbital and one P orbital is there. So that's why they form this type of, this is one sp hybrid orbital, this is one sp hybrid. They form two sp hybrid orbitals. Are you getting? So this one, listen, the number of hybrid orbitals formed is equal to the number of atomic orbitals involved in hybridization. Here one s orbital is there, one p orbital is there. They form two sp orbitals. Listen, if I separate it, this is one sp orbital, so this is also one sp orbital. That is the first thing. Listen, the hybrid orbitals are equivalent in energy and shape. The shape is also same. Both of sp means their energy is also same. Understood? So after mixing up, they form this type of hybrid orbitals. Okay, so these hybrid orbitals having similar shape, same shape, and as well as if both are s orbital, same energy, both are p orbital, same energy. Similarly, both are sp hybrid orbitals, then they are of same energy. So first postulate is satisfied. This is for what? Sp. So another one I will, that is sp2 means one s orbital. Okay, so one p orbital, another p orbital. When they get mixed up, they are not overlapping, they are mixing up. Then they form here one s orbital, p orbital, p orbital. Total one. Three orbitals are there. So three hybrid orbitals will form. One is like this, another one like this, another one like this. Okay, that is one triangle shape. This is S1, 2, P2. That is sp2 hybrid orbital. This is also sp2. This is also sp2. Three orbitals, whatever here formed is what? sp2 hybrid orbitals. Are you getting? And at the same time, the shape is triangle, and the shape of the individual molecule is also same. sp2. One s orbital combines with two p orbital form three sp2 hybrid orbitals. 1 plus 1 plus 1, 3. Here 1, 2, 3. Means the number of hybrid orbitals formed is equal to the number of atomic orbitals involved. So the first and the third postulate is satisfied. So the next one is the atomic orbitals taking place in hybridization must have same energy or small difference in energy. So how do you explain this? Okay. So for example, if you are taking configuration of carbon you are taking or nitrogen you are taking as well. So nitrogen atomic number is 7 and its configuration is 1s2, 2s2, 2p3. Okay. So students, if we write the energy level diagram for this is the lower energy. This is increasing order of energy. This is of course 1s option. This one is 2s. This one is 2p. If 3s we take, this is 3s, 3p, 3d. Means this is the energy level diagram. Means here 1s orbital is there, 2s 2p is there, 3s 3p, 3d, 4s is there. These are all having what? Same energy. And remember here, so 1s orbital cannot mix up with 2s orbital because the energy gap here is more. But 2s orbital can easily mix up with 2p orbital. They are having same energy because this is k shell, l shell, m shell, n shell. They are in the same shell. Somewhat energies are different. Okay? Compared to s orbital, p orbital is slightly greater energy. If n value is same, then they easily mix up with each other. They are having a small energy difference. For example, 1s orbital is there. 1s cannot be involved in hybridization. So it cannot be mixed up with any of them because 1s, 1p. S can only mix up with s orbital. But that type of hybridization is not possible. Only sigma bond they will form. But 2s, 2p, of course, they can overlap. Understand? When they overlap, so 2s orbital, 2p orbital, listen. So if we write the Bond's diagram, this is for s orbital, this is for p orbital. This is 2s, 2p. Means we need to consider the valence electron. Okay? Now, here 2 electrons are there, here these electrons are there. So consider I am writing NH3 molecule here. How many bonds are here? 3 bonds are here. Okay? So 3 bonds means we require 3 unpaired electrons. In the bonds diagram, how many bonds are there here? Whether it is a single bond or double bond. So that bond is going to be considered. Okay? So here 3 atoms are bonded. Here of course 3 single electrons are there. So no need for any other thing to do. So just consider the hybridization. So students, here consider this point. Both orphan and completely filled orbitals are involved in hybridization. So this one is completely filled. This one is half filled. No matter whether the semi filled electron is here or not. Okay, so we require 3 atoms, 3 bonds. If you want 5 bonds, then we can excite this bond. Okay, later while explaining the structures, I'll explain each and everything. Just remember, this 2s and 2p orbitals are there. They are of the valence shell, means completely these orbitals involved in hybridization. Which type? So this is 1 s orbital, 1, 2, 3 p orbital, that is sp3 hybridization. How many orbitals will form? 1s, 2, 3p orbital is 4 hybrid orbitals will form. sp3. sp3 type 4 hybrid orbitals will form. This is how the electronic construct, the structure of a hybrid memories, we need to take only the valence shell. Only the valence shell electrons are involved in the hybridization. Whether they are completely filled or incompletely filled. So initially what we thought? We didn't consider this. This one is considered the lone pair of electron. But here, this is involved in hybridization. No matter whether it is bonded or not, but those orbitals are also involved in what? Hybridization. That is mixing up of electrons. So mixing up of orbitals. Are you getting? So first one is did, second one also did, third one is also did. So fourth one. Next, the hybrid orbitals are more stable than bonds. Means the bond formed means either by sharing an electron or by transferring of electron, the bond will form. Means, for example, you take HCl. Okay, so here bond will takes place. Here what happens? The complete transfer of electron from hydrogen to chlorine takes place. Or it takes simply a sharing of an electron takes place. Here the orbital of this chlorine is with the chlorine only. Orbital of hydrogen is with hydrogen only. How the overlapping takes place? Hydrogen is S orbital, Cl is p orbital. Here only overlapping takes place. Only overlapping. S character is only for this, P character is only for this. Only the sharing of an electron takes place. But in the hybridization, they get mixed up. So the orbital form both HCl molecule. H is also getting sp hybridization. Cl is also getting sp hybridization. So compared to bonds, the hybrid orbitals are more what is it? Stable. Okay, compared to bonds, the hybridizations are stable. So why this theory is introduced, you know? So because the valence bond theory tells about the formation of a sigma bond and a pi bond. But it explains stability. Of course, it said sigma bond is the stronger bond, pi bond is the weaker bond. Only the formation or overlapping of the atomic orbital it explains, and it fails to explain how the bonds actually takes place. Why the three bonds takes place, two bonds, why only five bond, why sideways overlapping takes place, why axial overlapping. It fails to explain that. So to overcome that, this hybridization is introduced. That valence bond theory is a key concept for this hybridization. Okay. So next, the type of hybridization defines the shape of a molecule. You know, students, this completely defines exactly the perfect shape of a molecule. For different hybridizations, different molecules are there, different structures are there. So by explaining all the hybridization and its types, I'll explain the structure. Okay, I hope you understand these postulates. The postulates are very important for 3 months. They won't ask explanation than what I explained now. So they simply ask, write the silent features of hybridization. Okay, next. Next one is types of hybridization. Okay, so students, the first one is Sp. Okay, sp hybridization. So I write here one s orbital, one p orbital mix up with each other. This is s orbital, p orbital. Form two sp hybrid because as I told you, the number of atomic orbitals involved in mixing is equal to the total number of hybrid orbitals formed. If 1 has 1p, means 1 plus 1, 2. Two atomic orbitals involved in hybridization is mixed. their two orbitals are going to mix up. Then of course two orbitals are going to be formed. One is sp orbital like this. So another one is sp orbital like this. So two sp hybrid orbitals. Okay, so students, what is the shape here? Of course, it is linear. I write here. So one s orbital and one p orbital mix up with each other to form two sp hybrid orbitals. Okay, and the process is called as sp hybridization, or the phenomenon is called as sp hybridization. The shape of this molecule is linear. Remember this. The shape of this molecule is linear. So next, another one type is there. That is sp2 hybridization. sp2 hybridization. The name is concerns one s orbital, two p orbitals. Okay, one s orbital, one p, another p. So another p is of different plane. One s orbital and two p orbitals mixing up with each other, they form three hybrid orbitals. The shape of one orbital is like this. Okay, like this, three orbitals. That is 1, 2, 3. Okay, so this is what triangle. Okay, so how to write? Same, one s orbital and two p orbital mix up with each other to form three sp2 hybrid orbitals. So students, here remember, initially in the molecules I explained ab2, ab3, ab4 means we are considering b only as a bonds. Here including sp2, s plus 2p means 3 orbital we should consider like that. Orbitals, and the process is said to be sp2 hybridization. So students, here shape is no doubt trigonal planar, or you may also write triangular planar. Both are same. Trigonal planar or triangular planar. This is what sp2 hybrid orbital. So the next one is sp3 hybridization. sp3 hybridization. So remember here, one s orbital, 3 p orbital is px, p1, p7. So one x orbital and 3 p orbital, that is gas p, p, p. So therefore, listen, 1, 2, 3, 4 orbitals are involved in hybridization, means 4 hybrid orbitals will form. So here it is, I'll write. So here it is 1, okay, here it is 2, here it is 3, here it is. Okay, each orbitals are sp3 hybridized. Okay, the shape is tetrahedral. Okay, I will just write here 1 s orbital and 3 p orbitals mix up with each other to form, okay, 1 s orbital and 3 p orbitals mix up with each other to form 4 sp3 hybrid orbitals. Okay, and the process is called as sp3 hybridization. Okay, students, here the shape of the molecule here is what? Tetrahedral. Of course, you may also write here the bond angle, that is 180 degree. Here the bond angle 120 degree. So here the bond angle fixed it is. For tetrahedron means 109.5 degree. Okay, so this bond angle, everything is fixed. This is what type of hybridization. Mainly for your syllabus, only sp, sp2 and sp3 happen. Somehow, including the d orbitals also, the hybridization is possible. That is dsp2, dsp3, sp3d2, d2sp3, everything. Okay, so this one you simply consider this type of the molecule, how the hybridization takes place, and the shape of the molecule, and also this. Now I'll explain the different types of, except these three, how many types of hybridizations are there, what are their shapes, how the structures to be written, and what are the bodies. Okay. Okay. Yes. The types of hybridization: SP, linear, so bond angle is 180 degree. Later I will write the bond angle, just remember the shape. Okay. SP2, triangular layer. Sp3 tetrahedron. Next, Sp2 square planar. Sp3 trigonal bipyramidal. Okay. Sp3 square pyramidal. Sp3 and Sp3D. Next, D2Sp3 and Sp3D2. So both are octahedral. D2Sp3 as well as Sp3D2. How can you say? Listen, one s orbital, one p orbital mix up with each other to form two sp hybrid orbitals. One s orbital and two p orbital mix up with each other to form three sp2 hybrid orbitals. One s orbital and 3p orbital mix up with each other to form 4 hybrid orbitals. 1d orbital, 1s orbital and 2p orbital mix up with each other to form 2 plus 1 plus 1, 4 dsp2 hybrid orbitals. Next, 1d orbital, 1s orbital and 3p orbitals mix up with each other to form 3 plus 1 plus 1, 5 5dsp3 hybrid orbitals. Next, 1s orbital and this 3p orbital and 1d orbital mix up with each other to form 5 sp3d hybrid orbitals. 2d orbitals, 1s orbital and 3p orbitals. Similarly, 1s orbital, 3p orbitals and 2d orbitals mix up with each other to form 6 hybrid orbitals, and these are the structure of those hybrid orbitals. Understand? Now students, another one thing we need to know here is, so listen, linear shape, of course we can write them easily. The shapes are similarly. So this is linear shape, bond angle is 180 degree. This is sp hybrid orbitals. Next, triangular here, right? So the bond angle here is 120 degree. This is what? Sp2 hybridization. Next, Sp3. I simply write like this. Okay, I won't write small angles here. This is Sp3 hybridization. Bond angle here is 109.5 degree. Sp3 hybridization. Next, dsp2, that is square planar. So here the bond angle is 90 degrees. Like square, you know that. This is the square here. They are like this. Of course, the bond angle is 90 degree here. Okay. Next one is dsp3. This one is the structure. Triangular this one is triangle, this one is pyramid. That is Sp3D. Here the bond angle here is 120 degree. The bond angle here is 90 degree. Square, sorry, trigonal bipyramidal. This is square pyramid. Means 1, 2, 3, 4. So this one is square. This one is pyramidal. So students, the bond angle here is also 90 degree. Here is also 90 degree. All the bond angles are 90 degree. Square pyramidal. Why? How means result? Okay. So these are like squares. Square. This one is pyramidal like this. All are perpendicular to each other. Square it is. This is pyramidal. Means all are 90 degree. Okay. Next, this one is octahedral. So listen. 1, 2, 3, 4, 5, 6. Okay. This is what? Octahedral structure. In the yesterday's class, I wrote all the structures, but these structures are written in what? Sp3D2 and D2 Sp3D4. And the bond angles here is what? All are 90. So students, in the yesterday's class, I already wrote these structures, but in today's class, these are in the hybrid orbitals. Means which is the hybrid orbital here? For example, CH4 we are taking. These are the hybrid orbitals of this carbon. Means the orbitals present in the carbon, instead of overlapping, they mix up with each other. For example, carbon, that is 1s2, 2s2, 2p2. So here 2s orbital is there, here 2p orbitals are there. 4 bonds we require means here it is like this. So later it gets excited. Then what happens? The orbitals of same carbon, instead of bonding, they mix up. When they mix up, they form 4 hybrid orbitals of same energy, that is Sp3 hybrid orbitals. Means the atom of the central metal atom or orbitals of the central metal atom, they mix up with each other to form different hybrid orbitals. Means the structure is defined by these molecules. Understand? So this is all about hybridization and its structures. From tomorrow's class, we will discuss the percentage of S character and percentage of P character. What is their stability? Okay? Thank you.